Hey everyone, welcome to Earth's Changing Climate 4.1. Hey, we're in Chapter 4. Chapter 4 is volcanic eruptions and climate. Ooh, cool. I didn't know we were going to talk about volcanoes. That's awesome. In our lesson today is investigating volcanic eruptions. Here is our unit question: what causes climate change? So we're going to look at, hey, can volcanoes have any effect on Earth's climate? The chapter question today: how is Earth's climate affected in the 5 to 10 years after a large volcanic eruption? What do you think we're going to do? Well, we're probably going to jump into the sim, explore some things there. We're probably going to look at some evidence, and then we're going to wrap this up with a science seminar later. All right. Key concept today: while human activities are causing the current long-term trend of increasing temperatures, other factors can have smaller effects on the climate in the short term. What factors do you think we're talking about here? Well, we're talking about volcanoes, and we're going to see what kinds of effects those have. So we have two claims, actually, that we're going to be discussing. The first one is that a large volcanic eruption makes Earth's temperature warmer, and the other one, a large volcanic eruption makes Earth's temperature cooler. So, of course, again, we're going to be looking at data. We're going to be putting together the pieces to create an argument. So let's go ahead and jump into our lesson today, 4.1. But I'm going to read a couple things. First, I'm going to read our chapter introduction. Volcanic eruptions and climate. Humans are not the only factor causing climate change. Volcanoes can have a huge impact on the climate. Analyze evidence and decide for yourself what effect volcanic eruptions can have on Earth's climate and atmosphere. All right. I'm intrigued. I want to know more. Now I'm going to read for us the lesson introduction. Investigating volcanic eruptions. The head climatologist has one final mission for you. Scientists are working to understand the effect of volcanic eruptions on Earth's climate. Volcanic eruptions blast dust, ash, and gases into the atmosphere. Overall, does this cool or warm our planet? While volcanoes are not impacting the climate anywhere near as much, this is important, not anywhere near as much as human activities are, understanding their impact is still important for predicting and modeling smaller scale changes to the climate. Okay, so volcanoes putting all this stuff into the air. What is that going to do to Earth's climate? So let's go ahead and jump to our warm-up. And we got a letter from Irene. Here it is. From Irene Lee to student climatologist, that's you, the effect of volcanic eruptions. Thank you for your excellent, you're welcome. Welcome. Your excellent work. You've helped us explain to the public how climate change is happening on a large scale because of human activities, and now I have a mission for you. Did we do that? Oh, yes. Remember, we just wrote our argument, the blog post, and we made our models in the last lesson to show at least one human activity, how one human activity can affect climate change. Please help us research a smaller scale influence on climate. Major explosive volcanic eruptions affect the atmosphere, and we want to know whether they cause cooling or warming of the planet in the 5 to 10 years following the eruption. You'll examine evidence from several volcanoes, but mostly from Mount Pinatubo, major eruption in 1991, which is located in the Republic of the Philippines in Southeast Asia. Before drawing conclusions, you will discuss your claims and evidence in a few days in a group discussion called a science seminar. Hey, we've done those before. Looking forward to an interesting discussion. Well, aren't we? Hey, here's your question. What do you already know about volcanoes and volcanic eruptions? I'm sure you could all probably write a whole book about this, but let's go ahead and take a minute and answer this question right now. I don't know about you guys, but I like volcanoes. I think they're really interesting. There's so many different types of volcanoes, so many different places on Earth where we have active volcanoes. As destructive as they are also just fascinating and can be beautiful. So it's important to know more about them to make sure that we can be careful around them. Yeah, anyway, moving on. Hey, next is a video that you're going to watch. I've uploaded it to your lesson in Google Classroom already. So it's all about climate models and modeling. So go ahead, watch that video right now, and come back when you're done. So pause. Cool. I love it when we can actually see some of the things that we are learning in our class being used by professionals in the field, like we just saw in this video, how they use models, just like we're trying to learn how to create ourselves. They will create simulations. So a lot of the stuff that we are doing in our class and the practices and things that we're learning, they are transferable to a career that you might have someday in science or otherwise. Hey, let's jump into the sim now. we're going to experiment with, investigate, that's what I wanted to say, the effects of sulfur dioxide in the atmosphere. Sulfur dioxide is one of the gases that will come out of a volcano, along with carbon dioxide. Now, we've already looked at carbon dioxide quite a bit and its effects on energy entering and exiting Earth's atmosphere. But let's take a closer look at sulfur dioxide. So that's what you're going to do. It says run Earth's changing simulation until the time reaches 20, then pause. Increase sulfur dioxide to 500. So that's like the max, right? Run the sim until it reaches 40. Observe the changes to 1, energy entering and exiting, and also temperature. Make sure you check the graph. Where was the graph? Oh, yeah. In the simulation, if I go there, my controls will get in the way. But the graph button is right down here in the simulation if you go there. Answer the questions below using your results. So then it says continue running the sim and tracking the incoming energy to see what happens when it hits sulfur dioxide. Remember when we clicked on the arrows and it only highlighted one of the energy arrows, and then you could actually watch it and track it? We did that with carbon dioxide and methane. We watched energy leaving Earth interact with those gases, and then we saw that it got redirected when it hit one of those gases. It may have been redirected in a different direction out back into space or back down to Earth. So we're going to look at incoming energy now. And see what happens when it hits sulfur dioxide. So make sure you do that, answer all these questions. Go ahead and do that all right now. Pause. All right, so what should we have noticed? When we increased our sulfur dioxide, we should notice the temperatures went down. And why is that? So what happened to energy entering and exiting? We should have noticed that after we increased the sulfur dioxide, less energy entered than exited. And why is that? Well, let's go jump to the sim and take a look actually what is happening to the energy. When we play the sim, we can see that the arrows, the energy arrows coming in from outer space, from the sun, if they interact with that sulfur dioxide, they get bounced right back out into outer space. So unlike carbon dioxide or methane, which allow that energy to pass right through, this energy never even makes it to the Earth if it interacts with the sulfur dioxide. So that's one of the reasons why we do have less energy coming in than exiting, which will ultimately make temperatures on Earth colder. So let's move to the next thing, which is the student-to-student discussion. And it's just going to be you discussing with yourself and your imaginary friends. Using the evidence gradient. So I have evidence cards attached to this lesson for you to look at. And what you are supposed to do is decide which of the 3 cards provides the strongest evidence about the effect of the Pinatubo eruption on a global average temperature 5 to 10 years after the eruption. So here's our evidence cards. We have evidence card A, which is showing us global average temperature. Here's the Pinatubo eruption. Evidence card B, again, global average temperature and Pinatubo eruption, and evidence card C. Now, all of the dates are different on here. Yeah, the temperature ranges are different on here. So again, your task is to decide, which one you think is the most useful. And again, we're looking at 5 to 10 years after the eruption. We want to see what happened to global average temperatures. So go ahead, do that. Look at it, examine the evidence, and select your answer. Hit pause. I can't stop my video. Great. Let's jump to the homework. The homework is modeling, using the modeling tool. So what you're going to do is you're going to show how the path of energy is affected by carbon dioxide and sulfur dioxide. It's going to be side by side here. Let's actually open up the modeling tool and take a look at it. A lot of the things have already been put in for you. For instance, I believe the gases are already selected for you. Here it comes. It's coming. Trust me. All right, we'll just let that load. Let's go back to the directions. Goal, to show how the path of energy is affected by carbon dioxide and sulfur dioxide. So they're going to be side by side, and that's how you're going to show it. Let's see. Ooh, let's look at these tips. Incoming energy is given in both panels. You may choose to have the incoming energy hit the gas or the surface first. All right, what does that mean? What does that look like? Not that again. Ooh, it's still loading. All right, it finally loaded for me. So as you can see, energy is already in your panels, and also the correct gas. So we have carbon dioxide here, sulfur dioxide here. And all you're showing is what happens to energy as it interacts with these gases. What are we trying to show? So based on what we already know about carbon dioxide and based on what we have learned today from the sim about sulfur dioxide, go ahead and show that. And then as soon as you're finished with your model, make sure you click hand in and answer this question. It says, use your model to explain the effect of sulfur dioxide on energy and temperature. You can annotate your model if it helps with your explanation. So just basically describe, here's what happens with sulfur dioxide and energy. Here's how it affects temperature. The end. See you next time.